Hello viewers, this is Dr. Mercy Anthony, Assistant Professor and Head, Department of Statistics from St. Joseph's College of Arts and Science, Cuddalore. I hope you will find this video informative, and by the end of this video, you will be able to understand the concepts of F-test and its related problem with the solutions. First, we'll understand the conditions where F-test can be used. So the first condition is whether two independent samples have been drawn from the normal population with the same variance. And the second condition is whether two independent estimates of the population variance are homogeneous or not. So we have to remember 2 points. The first one is it should have same variance, and the second one is that it should be homogeneous. So the formula for F-test is F is equal to Sx square divided by Sy square follows F n1 minus 1, n2 minus 1 degrees of freedom, where Sx square is equal to summation x minus x bar the whole square divided by n1 minus 1, and Sy square is equal to summation y minus y bar the whole square divided by n2 minus 1. So this formula can be easily understood by one problem. So we'll go for the next problem. The problem is two independent samples of 8 and 7 values respectively has the following values of the variables. So here in the problem, sample 1 and sample 2 values are given to you. So the problem here is, do the population variance differ significantly? So as I have highlighted here, the population variance. So now as the problem is for variance, we have to go for F-test. So first what we have to do is, we have to check what is N1 and N2. So just count the values in the sample 1. So as in the problem itself, it is given samples of 8 and 7. So sample 1 is N1 is equal to 8 and N2 is equal to 7. So N1 and N2 is equal to 8 and 7. So this problem is of small sample. So here we have to first set up the null hypothesis. So the null hypothesis goes like this. The population variance do not differ significantly. That is H naught such that sigma 1 square is equal to sigma 2 square. So we know that the variance formula goes like this, the standard deviation whole square. So as we are applying the variance here, so sigma 1 square is applied here, right? So sigma 1 square is equal to sigma 2 square. So next we'll go for the alternative hypothesis. The alternative hypothesis is the population variance differs significantly. That is H1 such that sigma 1 square not equal to sigma 2 square. So once the problem is not equal to, so thus the problem becomes of two-tail. So next we'll substitute in the formula. So test statistics, F is equal to Sx square divided by Sy square. So we have to frame the table. So the first table, the first row will be for X, next is Y, next will be X minus X bar the whole square, next is Y minus Y bar the whole square. In X and Y, what we have to do is you just substitute the values from the problem. So the values are 9, 11, 13, 11, 15, 9, 12 and 14, and just find out the total values. So the X total value will be 94. Next we have to write the Y values. So Y value is 10, 12, 10, 14, 9, 8 and 10. And just if we find out the total value, we get the answer as 73. Next, what we have to do is we have to find out X bar. So X bar, as it is the raw data or individual series, the formula goes like this. X bar is equal to summation X by N1. So what we have to do is just we found out the X total. So it is 94. So that 94 is divided by N1, which is the number of values given in the sample 1. So that was 8. So 94 divided by 8 gives us the answer 11.75. So X bar is equal to 11.75. Likewise, we'll find out y bar. Y bar is equal to summation y by n2. So just we count if you count the number of values in y, we can see that it is 7. So 73 divided by 7 gives us the answer 10.43. So x bar is 11.75 and y bar is 10.43. Next, what we have to do is we have to substitute in this equation. It is x minus x bar the whole square. So if we substitute here, the first value will be 9 minus 11.75. So the answer, what we get there will be squared value. So 7.5625. That will be the answer for the first one. So next value will be 11 minus 11.75, which gives us the answer minus 0.75. And if we square that value, we'll get the answer as 0.5625. Likewise, 13 will be subtracted from 11.75, which will give us the answer 1.25. And if we square that value, we'll get the answer as 1.5625. So likewise, we'll complete this table. And if we find out that total, we'll get the total as 33.5. So that is for x minus x bar the whole square. Likewise, we have to calculate y minus y bar the whole square. So for example, the first value will be 10 minus 10.43, which gives us the answer minus 0.43. And if we square that value, we'll get the answer as 0.1849. So likewise, we'll calculate this whole values. So the value is given here. And if we find out the total value, we'll get the answer as 23.71. So this is our total of summation of y minus y bar the whole square. So next what we have to do is we have to substitute in Sx square. So here the Sx square is equal to summation x minus x bar the whole square divided by n1 minus 1. So what we found out was 33.5 was the x minus x bar the whole square sum value divided by n1 was 8 and n1 was 8. So 8 will be subtracted from 1. So 8 minus 1 gives us the answer 7. So 33.5 divided by 7, the whole answer will be 4.78. This is our Sx square. Next we have to find Sy square. So Sy square is equal to summation y minus y bar the whole square divided by n2 minus 1. So what we found out the total value was 23.71. So 23.71 will be divided by n2 minus 1. So n2 value was 7. So 7 minus 1 gives us the answer 6. So 23.71 divided by 6 will be 3.95. So we found out Sx square and Sy square. Finally, we have to substitute in F formula. So F formula is Sx square divided by Sy square. So 4.78 divided by 3.95, which gives us the answer 1.21. So this is our F calculated value. So what we have to next check is we have to go for the table value. So the table value can be obtained from F table for n1 minus 1, n2 minus 1. So if we calculate that value, that gives us 7,6 degrees of freedom at 5% level of significance. So the table value is 4.21. So this is the table value. So the last step will be of writing the inference. So what we have to do in the inference is we have to compare the table value and the calculated value. So how we conclude is if our table value is, if the calculated value is less than the table value, we'll be accepting the null hypothesis. Otherwise, we'll reject our null hypothesis. So in this case, what happens is our calculated value was 1.21 and the table value here is 4.21. So our calculated value is less than the table value. So thus we'll accept our null hypothesis. So that is the population variance do not differ significantly. So with this, the problem ends here. Next, we'll see the second problem. So the problem here is Time taken by workers in performing a job are given below. The method 1 and method 2 values are given here. So what we have to test is, test whether there is any significant difference between the variances of the time distribution. So this is the problem. Again, in this problem, the variances is given here, specified here. So we have to go for F test. So we'll start with N1 and N2. So if we count in N1, how many values are there? So 1, 2, 3, 4, 5, and 6. 6 values in method 1. So that is our N1, and N2 is 7. If we count in method 2, so method 2 is N2. And then we have to write null hypothesis. So null hypothesis will be for this problem, there is no significant difference between the variances of the time distribution. That is sigma 1 square is equal to sigma 2 square. That is our null hypothesis. Then alternative hypothesis will be there is significant difference between the variances of time distribution. That is H1 such that sigma 1 square not equal to sigma 2 square. So that is, this problem becomes again two-tailed test. So next we will go for the test statistics. So the formula goes like this. F is equal to Sx square divided by Sy square follows F of N1 minus 1 comma N2 minus 1 degrees of freedom. So next we'll substitute the values in the table. So like the last problem, we have to find X bar, then Y bar, Sx square and Sy square. So X bar will be, we'll find out the X, summation X value. Here in this problem, summation X is 134 and total of Y is 241. So once we found out the total value, we'll substitute in the X bar and Y bar. So X bar is summation X by N1. So 134 by 6, which gives the answer 22.3. And Y bar is summation Y by N2. So 241 by 7 gives us the answer 34.43. Next, we have to substitute in Sx square. So Sx square will be summation X minus X bar the whole square divided by N1 minus 1. And so once we substitute here, that value will be, if we check this, this is X minus X bar the whole square. And Sy square is equal to summation Y minus Y bar the whole square. So just if we substitute in this formula, what happens is we get the answer as Sx square is 16.3 and Sy square is 22.3. So like the previous problem, if we calculate, if we substitute in this formula, F formula was Sx square divided by Sy square. So if we substitute in that method, the values will be 16.3 divided by 22.3. So if we check here, 16.3 is less than 22.3. So always what we have to remember is the greater value should be divided by the lesser value. So thus for that reason, we have to change the formula here. So now the Sy square divided by Sx square, that becomes the formula, which will be followed by F of N2 minus 1 comma N1 minus 1. So in that case, if we substitute the values here will be 22.3 divided by 16.3. So which gives the answer 1.368. After that, we have to check the table value. The table value can be obtained from 6,5 degrees of freedom at 5% level of significance. So here the table value is 4.95. So once we found out the table value, what we have to do is we have to find out we have to write up the inference. So what we have to conclude here is, again, we have to compare the table value with calculated value. So here the calculated value is 1.368 and the table value is 4.95. So thus we will be accepting our null hypothesis. So that is, there is no significant difference between the variances of time distribution. So with this problem, I'll end up this session. So hope you understood the F concept. Thank you for your attention.